Well, there we are. Well, good evening, graduate UNSY students. Just first, as a reminder, we are recording this session, and a copy is going to be made available for those who are unable to attend tonight. Next, for the format of our meeting, I'm going to start by introducing our guests, and then we're going to proceed into an interview-style discussion. After that, I'm going to open it up to a class-wide Q&A. I do ask that you all mute your mics, save any questions you have until the end, and that you do use the hand raise icon to indicate when you do have a question, and I'll call on each of you in order. With that, I am just really thrilled to welcome you to the 45th session of the Uncrewed System Guest SME Speaker Series. This is the third and final for the term. I'm Dr. Brent Terwilliger, the program coordinator of the Master of Science in Uncrewed and Autonomous Systems degree here at Embry-Riddle Worldwide. Tonight, we're joined by our guest subject matter experts from Ellipsoid AI, CEO Amir Basernia and CTO Abhi Verna. Over the course of our discussion, we're going to explore the cutting-edge intersection of artificial intelligence and uncrewed systems with our guests. And they're going to explain to us how their focus on revolutionizing physical AI through large-scale synthetic data generation, how it's spanning industries, including robotics, aerospace, and computer vision. This is extremely relevant to what we've been looking at these last 9 weeks. With that, let's get started to see how they're helping to shape the future of smart uncrewed system technologies. Amir and Abhishek, welcome to the class.
Thank you.
Thank
So
you,
I'd,
Brent.
I'd like to start out with just a background question. What inspired the founding of Ellipsoid AI, and what gap in the AI ecosystem are you working to fill right now?
Amir, do you want to take it?
Sure, I do it. So for mission critical systems, what we've learned, and probably it's not a surprise to you or your students, collecting data in the real world is actually the gold standard, but it's a very slow and expensive process. It's not scalable. And that's basically the fundamental limitation to safe deployment of these physical AI systems, because you want to make sure that you have enough coverage in your training data for all situations and corner cases, especially the cases that you don't encounter very often. So that requires extensive testing and training, and that would be very time consuming in the real world.
Was there a particular project or maybe even a specific experience that shaped the approach that you're working right now?
Absolutely. So Abhi and myself met while we were working at Airbus in the autonomy team at Airbus. And a good example, which is not even a corner case, is that airplanes typically land and take off at airports. But airports are very controlled and restricted environments. You cannot approach, just fly into an airport. You cannot fly drones around an airport. So really, it's very, very difficult to collect data around airports when you want to train an AI system. And that was basically the idea that for certain cases, not only collecting real data is expensive, sometimes it's impossible. Another good example would be space. You are not going to send a probe to Mars to collect data in order to send a second probe to Mars, right? That's the non-starter. So this basically was the reason that we were convinced that we are onto something.
So the crux of your focus is on high quality synthetic data. Can you
Mhm.
walk us through what exactly is high quality synthetic data, and where does it tie into autonomy and robotics or uncrewed systems?
Great question.
Right. Um,
Do you
Abhi, you
want?
take that one.
Oh, okay, sure. So quality is such an important question. So my background has been in flight simulators and in that side of the world when you're training human beings. The way or the lay of the land used to be that you bring in the subject matter experts who have seen the real sites and real operations to kind of define or bring down the bottom line of what exactly a simulator needs to look like in terms of quality. Luckily, when we train AI systems, a lot of this quality that we talk about is quantifiable. So for the ML algorithms, when it comes to actually seeing if a particular frame that has been generated synthetically, there are these ML-based approaches that you can take to kind of see how the features in your frame, how realistic they are. But what we found out when you're using this data to train ML models, the most effective way is just comparing uh, sim to real gap is the frame that we use of an ML model that was trained on the real data versus the ML model that was trained using synthetic data and equivalent synthetic data. Now, you asked the question about how does it relate to physical AI and autonomy use cases. So, in physical AI, especially when it comes to mission critical applications, deterministic performance of these ML models is basically the key. So, quality of synthetic data matters quite a bit. Rather, in the interviews as part of Ellipsoid's discovery process, we talked to a lot of industry folks. Basically, what they told us was a lot of the synthetic data solutions seemed super interesting and the only way to scale, but they basically could not use that as part of their training data. And the reason was the sim to real gap. Rather, they also told us they were okay spending this extra cost and time collecting this data in the real world, which they understood is unscalable, but kind of is their only option. Now, this is true for verticals that like self-driving cars or drones, but when you transition over to the use cases that we are talking about today, aerospace and defense, this is not even a cost question. This is more of a safety one. So
Okay.
quality is super important.
Can you walk us through how your platform creates the synthetic data sets? What inputs are required? What do you need to do to tune your models?
Absolutely. I take this question. So here is the fundamental observation. Collecting a small amount of typical data is not the biggest challenge. Like, for example, you can fly an airplane, a drone, or an autonomous system to collect some typical data that is not necessarily unique. At the same time, we can envision a lot of corner cases or rare scenarios that would be interesting to train the AI on. So combining these two is basically the basic idea of this approach. So what we do is that we use generative approach, a generative AI approach. We train the generative AI on typical data, a small amount, and there are different interpretations of what small means, but with a smaller set of real data that we collect from the actual platform that Autonomy is deployed on. We use that data either for pre-training or fine-tuning a generative AI model. And this generative AI model now can be used, can be leveraged to generate a lot of synthetic data. But again, most of the synthetic data might not be super interesting. So how do we approach that? Basically, we combine it with scenario generation, novel scenario generation, and we create synthetic data for the scenarios that are interesting. I give you an example. For example, for aviation, probably the scariest thing and the most safety critical aspect is mid-air collision, one of the big ones. Probably you don't want to collect such data in real world. But doing it in, through synthetic data is quite straightforward. So basically, that's the approach that we take.
how customizable are your scenarios in your generator, or are they very domain specific from the get-go when you train it and then use the Gen AI aspect to create it? Do you have to tailor it from the front end, or is it something you can adapt afterwards?
Both. So I would say the answer is that when you have a Gen AI model, typically at least with the current iteration of AI models that are available, and we're talking about the state-of-the-art models, they are not going to be able to generate data that they've never seen. So they are as good as their training data. So we cannot expect to generate synthetic data that we've never seen, like domains that we've never seen. So there has to be an element of either pre-training or fine-tuning of these models. However, these models get a fundamental understanding of the data in a way that they can interpolate data in very sophisticated ways. So you don't need to have something super close to the scenario that you want to generate, as long as you have enough diversity in the training data. And that's one of the both challenges and opportunities because definitely we would want to improve the performance of our Gen AI pipeline over time by adding more training data. But at the same time, the real value, like I said a couple of minutes ago in my answer to your previous question, is that scenario generation is really critical. So we are not going to let the AI, Gen AI loose, and so it tells us what it wants to generate. We are going to put very strict conditions on the output of the model basically by designing the scenarios that we want to generate data for. So that's generally is that you have to have a very tight control over the scenarios.
And just to add another quick point there, so when Amir mentions about conditioning these models, typically people assume that it's through text prompting. And in our experiments, even if you have trained the model on domain-specific information, these models typically, once you have generated videos of more than a couple of seconds, they start to hallucinate pretty badly. And those types of situations for our use cases are just simply a no-go. So the conditioning is used with the prompts, but the prompts are not necessarily the text prompts, but they are more sophisticated prompts. One example could be a medium fidelity simulation scene, for example, could be used as a prompt. And there are
It,
multiple sophisticated ways to do it, but I just wanted to give that as a broader view of what we mean by conditioning these models.
So,
Exactly. That's I just add one more last point to this. Yeah, the prompt, think about the prompt of any kind of data. So probably you've seen in Gen AI models, sometimes the prompt is another image. But the concept of a prompt is way more general than that. So for example, the velocity and location of your aircraft could be
Yeah,
part of the prompt. So it could be a lot of rich information about your environment that could be a prompt. And that prompt conditions the Gen AI model to provide and create the correct desirable result.
so earlier you were mentioning traditional simulation, to get it to that higher fidelity, you're usually working with a SME, a subject matter expert, who's
mhm,
familiar with say, the aircraft or the environment. In this case, you're not always reliant on that SME to fine tune your output. You can use other data sets. You can use a variety of inputs
yeah,
to really self-reinforce what you're outputting to get it to where you need it for purposes of things like VMV, validation and verification.
correct.
And that's one of the big use cases, right, of your product is for validation verification of a tool set or a mechanism for say testing an eval of an aircraft to get it through type certification.
Absolutely.
Right.
What I would say to that is that probably the best subject matter expert would be the actual data that you collect from the platform. Typically, of course, a lot of work goes into that, but usually sensors have so much nuances and so many characteristics that are hard to capture in a simulation. So why not use it as the training data directly so those nuances would be naturally included in your ML model? So you wouldn't even have to think about that. It's actually a natural byproduct of your workflow.
So in
Now, sorry to interject really quickly, though, we should not discount the relevance of subject matter experts even in this side of the process, mainly because, again, going back to conditioning. So creating these scenarios, knowing what stress tests to test these systems on, actually generating these underlying input simulations, the lower fidelity simulations that are used as inputs. Subject matter experts, I think, are still critical in that part of the process. Knowing exactly what could go wrong when these are deployed are still very key pieces of information that will get these systems through with the certification process. So I don't want to discount that part. Just wanted to mention that out there.
So that actually ties into an observation set we have with just Gen AI at large. Because earlier you mentioned, this technology can start to hallucinate early on, and that'll perturbate and cause, pretty notable side effects.
Mhm.
We'll put it that way. It's your SMEs that are going to be able to, in most cases, recognize that early and often. In much the same way that, say, writing that's reliant on Gen AI, it experiences hallucinations that somebody who's not necessarily familiar with the material it's covering, they wouldn't be able to recognize. Whereas if you take a SME and they review that, it usually becomes very apparent. Oh, we see where this came from. It was Gen AI produced,
Yeah.
and it's
Absolutely.
so it's excellent.
Uh,
Yeah, just
could I add a
adding,
quick point there?
go ahead.
Uh, so actually, the use of SMEs to detection of hallucinations, that's actually where I would want to put a short of a sales pitch for Ellipsoid AI here. So that is one of the things that we are working hard that should be an automated part of the process. So our main goal in leveraging these generative AI models, though we are training them and we are trying to make sure they are the true reflection to the unbiasedness of the domain, we still are very focused on using these models with proper conditioning that the results are these multimodal sensor outputs that are consistent not for just a couple of seconds, but actually even hours of training data.
Okay. So earlier, Amir, you talked about one of the benefits being safety. Mid-air collision, you don't want to actually have to do that in the real world. Uh, what are some of the other advantages of using synthetic data, say in uncrewed systems, whether it's for training or type certification of a new aircraft, compared to traditional simulation or real-world data logging and analysis?
Right. So real-world data logging is the gold standard. Um, I personally don't believe that synthetic data would ever replace real-world data collection entirely. Our hope is to reduce the need of real-world data and expediting the process of training and deploying these systems in a safe way. But at the end of the day, we have to do some physical testing, especially in aviation and defense. It's always been the case. Now, with respect to the comparison between synthetic data, the new way, and traditional simulations, like we discussed, building traditional simulations really requires a major investment upfront. Typically, you need to build high-quality 3D assets and environments. That is typically a slow, expensive process. But also on top of that, these systems are geared towards training human operators, and they are really good at that. For example, a flight simulator is used for training pilots, and it has uh, proved itself to be a very effective tool. However, we need this new kind of simulation where we could leverage all this new AI technology that we have to train AI. And in this new domain, sim-to-real gap becomes a major challenge. So we all know that computer games or flight simulators or any sort of synthetic data in many cases doesn't look real. Like it looks like we say it looks like computer game, it doesn't look like a real photo, so on and so forth. So in more technical terms, the distribution of synthetic images is slightly different than the real images. This would introduce itself as a form of bias in the training of this AI, which could compromise the safety when you actually deploy this AI. And that's something that any person or industry who is operating in the physical AI space cannot tolerate, any sort of compromise on safety. So the bias and safety of the data is of utmost importance, and that's why the traditional simulation industry did not have to worry about that. But what I see personally is that there will be a convergence between these two domains. Like traditional simulation tools over time become more and more realistic, like become like real sensor data. And at the same time, the synthetic data from generative AI models will be used more and more in simulation, traditional simulators like flight simulators. So I think this distinction in the future will be a lot more blurry and the line would be a lot thinner between the two. But I think fundamentally today, sim to real gap is the fundamental distinction.
Okay. Can you walk us through some specific examples of where your synthetic data can really support uncrewed aircraft or autonomous ground vehicles or maritime systems, different platforms or use cases within the uncrewed systems
Mhm.
world?
Yeah, absolutely. So we already talked about mid-air collision, and there has been really unfortunate incidents recently. One was in Washington, D.C., but another one happened in Tokyo about 1.5 years ago. It was at night, and aircraft landed on the Japanese Coast Guard aircraft on the runway. There was a runway incursion. Runway incursions and debris or obstacle or objects on the runway or anywhere in the aerodrome, that's a major challenge, right? And sometimes they are not visible in the visible spectrum, like visually, because it's dark or for whatever reason, the pilot might not have enough awareness. So these kind of things definitely would matter. Another one that very specific use case that became very important recently, operating in GPS denied airspaces. Like many people are talking about that problem these days, especially if you are in low light conditions. Like how would you operate in an environment that basically you are not sure where you are? That's another domain that, using advanced sensors and training AI as a mean of pilot augmentation. This is not fully autonomous system, but it would augment the pilot functionality. That's another big use case. Then we have another use case, like things like, target detection or landing zone detection. Um, just imagine, now this is more on the commercial side, but we are talking about delivery drones. We've been talking about them for the past decade. There are challenges, there are regulatory challenges, and there are technical challenges. But how do you deploy these machines and drones in a safe way? Like, where are they going to deliver the payload? So it's a payload that you want to deliver to a residential address. Like, do you just drop it somewhere on the backyard? What if there is a danger? What if there are kids playing there, you know? So when you think about all these use cases, it's really that, you know, using computer vision and other sensors could be very important for a safety and you know, safe deployment of these platforms.
So your synthetic data, you cover terrain and, you know, complex operational environments like, say, urban canyons, cluttered maritime environments, or perhaps even forested environments for that last mile delivery example, where you might have tree cover, tree canopy that's spotty, and you have to figure out, is this an area I can land and deliver in?
Exactly, exactly. And finding the right environment, of course, like I said, physical testing will be necessary. But when you think about all the combinatorial explosion of possibilities, like, for example, I have a tree canopy and like I have a residential building there, or there is a road or power lines going over that area. If you think about all those possibilities, collecting data in the real world becomes a challenge, but you can create those synthetic environments quite effectively and quickly.
So realizing you guys are a startup and you might have a lot of NDAs in place and things like that, I understand if you decline to answer the next one, but at the moment, do you work with or plan to work directly with OEMs, researchers, or commercial simulation environments like Unreal?
Uh, we can answer that, and the answer is very clear. The OEMs, because they are the ones who are building these autonomous systems. So right now, we would prefer to work with people who are building the platform and people who are operating the sensors. There are multiple reasons for that. One is the efficiency of the process. Like, basically, this is the system that is going to be deployed directly, so you get first-hand experience from people who are building that. The second one is that having access to the sensor data is a huge advantage. So um, probably you wouldn't want to have access to, you know, similar data, but not the exact data that you are going to deal with. So having access to the sensor data is important, and you want to use that potentially for fine-tuning your models. Um, and the last thing is that, like I said, um, this is just why simulation environments are not the ideal platform for us to engage right now. Most of the focus is not on AI training for systems like Gazebo or Unreal Engine or AirSim. Some people are using them in that capacity, but that's not the main reason that these systems were built. So generally, it's a little harder to adapt the use case to AI training. And it's just easier if you start sometimes from a blank slate. And by the way, it's not to say that we don't use these tools, but it's,
Yeah.
you know, it's extra work.
Okay. So this last week, the class looked at ethics and regulations as they relate to uncrewed systems. You talked a little bit about bias that can occur in the generation process. How do you
Yeah.
address concerns related to bias, as well as transparency or even ethical AI in your business model when you're generating synthetic data?
Yeah, actually, I can take that. So, this is actually an issue that we are tackling basically at the core of the data generation pipeline. So, it is very critical. I wish this was not the case, but it is very critical for us to leverage generative AI, basically to achieve the scale. But with what we are doing at the core of the technology is we are leveraging the predictability of the simulation environments as inputs to control these models. Further, to reduce the risk around biasness even more, we are leveraging, as we talked about, the real world data to retrain these models to understand the nuances of the domain, basically to target uh, these models to basically target the domains where these will be deployed. So those are the fundamental differences between us and using pure diffusion model based synthetic data generation models. That allows us to very inherently remove biasness from the synthetic data that we are generating. So that's one aspect around it. Um, does that kind of answer the question? I know it's a very broad question.
No, that works really well. So, kind of wrapping things up, what's next for Ellipsoid AI? What new domains, technical challenges, or even cross-sector opportunities are you starting to explore?
Um, I guess you know as well as we do that AI is evolving and expanding rapidly. So it's extremely hard to predict what's next in general. But it seems that the AI that we have today is the worst AI that we will ever have. Like tomorrow will be better than today, and next year will be better than tomorrow. And there will be two things. One is that AI is going to get better at any single task, but also there will be more tasks that AI will penetrate and would impact. So for Ellipsoid AI per se, we are definitely looking at the new frontiers. Like I said in the beginning, like space is one of the ones that is very promising. Aviation is still a new a domain because of the safety considerations. Rightly so, the regulators are not going to allow this AI to be deployed today without any sort of regulatory and safety oversight. So that's a good thing. But also it means that there are a lot of opportunities because the deployment of AI is going to happen in phases. So there are a lot of opportunities in aviation already, but I think there will be a lot more, and space is an interesting one. But if I want to, this becomes a little bit of science fiction. But if you think about AI in the future, like basically we want to have systems that are basically systems that uh, show superhuman capabilities in terms of sensory cognition, uh, uh, coupled with decision making, complex decision making capabilities. Um, Also, another domain that is interesting is that um, human brain operates, it's very energy efficient, like a human brain operates between 20 and 50 watts. These AI systems are still deployed on big data centers. Deploying AI at the edge, like for example, you have a drone with a small battery, you cannot spend all that power on of all that energy on like AI inference on the drone. So making them more power efficient and how you would implement them on the target hardware. So these are all challenges that's going to come to a head in the next couple of years or couple of decades. So we're super excited about those, but for the most part, right now we are focused on new verticals.
Okay. How might graduate students or even researchers get involved, whether it's through data partnerships, internships with you guys, or pilot projects, maybe even?
I mean, we love embry-riddle, so all of the above. But more specifically, we are at the stage of the startup right now where we are onboarding some very cool pilot projects. These are all like autonomy use cases where we are building these generative AI models to generate synthetic data for them. I mean, if it's okay with you, we would love to post some like staffing announcements around those
Oh, yeah.
projects to kind of tell you what we are looking for. We would love to see if there is an interest on the other side, but we would love to partner with your students. We know it's a very reputed organization.
Excellent. Yeah, and then, as we kind of evolve this discussion, there could be great opportunities to get direct student inputs into perhaps new use cases or applications. So that's something I think that's definitely worth talking about. Well, on
Absolutely.
that,
Um, also, I just quickly wanted to mention the STTR collaborations as well, because as Amir was talking about, like these new verticals, the challenges are uh, evolving as well as the problems are. So, a lot of interesting STTRs are being posted around these topics. So, we would love to engage you on those as well.
excellent. Well, I think this is just a great time for us to open up the floor to all of you that have waited patiently. Please go ahead, raise your hand, and I'll call on you in order so we can give you a chance to ask your questions. Where is the hand?
Uh,
It's under React. It's like it looks like a heart. All right, Laura, go ahead.
Hi, Amir, and I'm gonna butcher your name, so I really apologize, and it just disappeared. Um,
I go by Abi.
Abhishek.
Thank you, Abi.
Okay. Thank you for your presentation. Especially since you mentioned the recent mid-air collision between the helicopter and the plane in DC earlier this year. I'm curious. You talk about the ability of simulating these different collisions. Are you also being requested to simulate or validate previously like previous accidents from the reports to like validate the findings or the reasons for those accidents that occurred?
No, we have not been asked to do that, but I would say this. Typically, when you want to create this kind of scenarios, we are talking about a very, very vast number of scenarios, right? I give you an example, like very simple example. Imagine you want to train a robot to walk. We know that the strength of gravity on Earth is some number like 9.81 Newton meters per second squared. But to make sure that this robot will be robust, we are going to change the value of G in the simulation, the gravity, to make sure that this robot would be able to, if in the sensor, for example, there is some error, if the accelerometer on the robot is not quite precise, it would be able to tolerate that sort of error in the perception stack. So that brings me to the question about the mid-air collision. Basically, you would take some scenarios based on known history of how this collision happened, but you add a lot of diversity to them to create probably millions of scenarios in which these kind of mid-air collisions or runway incursions could happen, right? So it's not specifically about a certain scenario that happened. It could be, I give you an example, like for example, the worst aviation accident ever was the Tenerife accident, two 747s, I think it was 1976, collided on the runway. One was taking off, another one was crossing the runway. And that was because of fog, right? So then it becomes, changing the fog density in your simulation and creating all sorts of visibility conditions for the pilot or the camera to train this AI to see to what level it can tolerate this sort of adverse weather conditions. So definitely using the historical data is a must. I think no one can claim that we should ignore that, but it's to leverage the historical data to create a lot of scenarios around those. That's the real value.
Thank you.
Anthony.
Yes. Hi. Hey, everyone. Loved your presentation and everything that you were going over. This is very interesting to me and what I've been looking at doing possibly in the future as a career. One of my questions was, what is the limit where you determine that real world testing and data is necessary? Because I know that you said that you input the certain variables and conditioning that you want the AI to generate off of. So at what point do you determine that either more or just realistic data or some type of real world testing is needed to continue to generate more scenarios?
Absolutely. Abi, would you like to take that?
Sure. So it really is dependent on the model that we are building. So the model that we are talking about that generates the synthetic data has been trained on different domains. So when we are entering a completely new domain, that amount of data that you ask, that you require as the training data is typically pretty large. Um, Typically, what we leverage is usually these campaigns that these autonomous use cases would run to collecting data. A couple of these campaigns were together. This is now I'm talking about a domain that we have no training data whatsoever on. Um, a couple of 100,000 of those images across multiple sensor modalities are typically enough. Having said that, that typically is never the case because most of these foundational models have a lot of insights into the real world already. And as Amir said, we are at the stage where these models are the worst that they will ever be. Uh, so as we are moving along in this process, uh, the requirement for the data that you just asked, it keeps going down. Amir,
I
do you
would
want to add more to it?
I would just add one more point. Um, so Anthony, first of all, I'm really glad to hear your enthusiasm about this subject because I'm super passionate about it myself, and I chose it as a career for myself. Secondly, I don't think you would ever replace real-world testing with simulation and synthetic data, especially when it comes to human life and safety considerations. You have to have some real world testing that gives you enough confidence about the safety of the system. So that's one. The second thing is that it's kind of not very hard uh, to evaluate the performance of the synthetic models and data for training, not testing, for training. And the way it works is that you have some real world data, that's fine. You add synthetic data and you add more synthetic data and you add more synthetic data. The performance gets better and better and better. At some point, this performance peaks. When you see that you are starting to see some degradation in performance by adding more synthetic data, you realize that actually the bias in your data is taking over. Now, our hope is that the bias in the synthetic data would be so small that you always make the performance of your model better and better by using synthetic data. We are not there yet today. And by we, I don't mean Ellipsoid AI. I mean generally the AI community at large is not there today. So you want to have a mix of real data and synthetic data for training. And by doing so, you accelerate the training process. But I would recommend to rely mostly on the real data for safety critical testing of the system.
Yeah, thanks for
Definitely.
clarifying that. Testing is different from training. Yep.
Sorry to interrupt you. But yeah, I definitely agree. Thank you for acknowledging my interest in the field. So yeah, that kind of goes full circle with what you were saying about the subject matter experts being brought in those instances to confirm whether or not it's on a ramped or if it's actually realistic data being produced.
Yes, yes. I wanted to add actually one point on that. It's funny because it happened. We were talking to Abhishek a few days ago, and we were looking at the synthetic data, and Abhi told me, "Oh, this doesn't look super real." And I said, "Can you explain what's not real in this image to you?" And he was like, "I cannot put my finger on something, but it doesn't look real. And that's one of those things that with this kind of nuances, we know when the data is not good, but it's hard to explain it. So when it comes to subject matter experts, this is just an advice that I learned the hard way myself. Try to think and try to be curious at the system level, high level of the system. That would be where the AI would be the worst and the weakest. But when it comes to, say, the nuances of the noise profile of a sensor like camera, that's where that AI and machines do better than humans, because that becomes super subtle, super quantitative. So we want to leave those kind of nuances to the AI and to machines. But when it comes to high-level decision making, I don't think AI has a chance of replacing humans anytime soon. Maybe, I don't know, maybe in a century or something, but not anytime soon.
So I think that's entering into similar in robotics and kind of humanoid graphics. It's that uncanny valley. When something it doesn't quite match up with your expectation or the common perception that you're used to, and you can't exactly quantify it, you can't exactly explain what it is about it, but it's even just something so different, so slight that it becomes off-putting. And you say, I don't want to, I don't want to look at this. I don't want to use it. I don't want to be near it. That's what happens in those, like sometimes in computer animation. Um,
Yeah.
Folks, did you have any other questions for our guests? Oh, Laura?
I'll ask again. Within your community, what discussions are there regarding possible regulations coming down and limiting your ability to actually continue the development? Are there any concerns for you in the very near future with that?
Yeah, from what I can talk more from the aviation perspective on our experience with working with Airbus, for example. FAA right now is trying to work with communities and partners like us, basically to defining those requirements. Like for simulators, Level D was a well certified and well established system that was put into place. There has not been any system to certify synthetic data pipelines yet. They have defined on what ML performance are they trying to get out of these autonomous systems, and that's where the certification kind of ends. I'm sure in a couple of years they will put more guardrails around that. But from what I understand, right now they're looking for inputs, FAAs at least.
Um,
I'm not. Go ahead, Amir.
Yeah, I just add one thing. Definitely, FAA is involved in the process, and as a matter of fact. But here is the thing: Silicon Valley, maybe rightly so, but unfortunately has this reputation for moving fast and break things. I personally think that in this case, at least I've not seen that attitude. Like I personally embrace regulation because, like I said, when it's a safety critical system, you want to be very cautious. You don't want to just be cavalier with deploying something that is not safe. So when it comes to, for example, aviation, and we see that, like for example, deploying self-driving cars poses less safety concerns, but even that has been fairly slow, right? With
Yeah.
aviation, I don't see a world in which that we don't have autonomous aviation today and we will have it tomorrow. I think it will be a very gradual process. I would see the drones being autonomous. Actually, we have autonomous drones today. But beyond that, I see that cargo planes will be automated before passenger flights. Also, when it comes to aviation, most of these systems will be deployed as augmentation. So for many years, the industry will collect data to compare the decision-making process done by the machines versus the human pilot. And probably at some point in the future, it will be deployed as a fully autonomous system. So I don't think regulation being an impediment. It's just something that guarantees a safe deployment of the system.
Yeah, we could be making a lot more money very fast if we just move away from the mission critical applications. But that's where our passion lies. We really want to make sure we are pioneers in doing it right.
Thank you.
Excellent. Well, on that, are there any thoughts you'd like to leave our graduate students with regarding the potential of this technology?
I touched on it, briefly. I would say when it comes, it's funny because it was this joke that I wanted AI to wash my dishes, so I do art, not AI doing art for me while I still have to wash the dishes. So basically, for a lot of jobs that we really need AI to help us the most, the capabilities are lacking. We really, at least the way I feel, we don't need more video generation for creative purposes. We need AI that brings more safety to the world. And I see that physical AI has a lot of potential on that front. So I would encourage everyone to think about, what is that, how this AI should evolve in a direction that makes an impact in the way that benefits us as a human society, rather than being something, being a solution looking for a problem. And I think some of the AI applications that we see today are solutions looking for a problem. I don't believe physical AI is one of those. So I think it's really a valuable endeavor to work on.
Excellent. Well, on that, I just want to thank everybody for joining us tonight, as well as just a huge thank you to Amir and Abhi for sharing your thoughts and expertise regarding where AI-generated synthetic data is heading. This has been just a tremendously informative session, and it helps us to better understand the challenges, the capabilities, and even the opportunities that are associated with this capability-enhancing technology. Students, for full credit, remember you need to add a brief discussion entry, a single post by Sunday. No peer replies are needed. You're going to identify that you were in attendance, describe how any new information you were not familiar with, and then explain how your overall understanding of the topic has improved. I do hope to have a recording from this session uploaded to the Instructor Corner in the next day or two. And with that, thank you all for attending.
Thank you
Well, I
so
would,
much. Good to meet you all.
yeah, I would like to thank the opportunity. It was an honor to be here. Thank you so much, Brent, and everyone else.
Same guys.